Okay, hello again. We are going to finish chapter 2. I'm going to do the last section and I'm going to do the exercises, go over the exercises in that section in the textbook. And as I go over the exercises, I explain the concepts as well. Now, I did one more thing. I deleted one assignment, which is this last one right here, from the assignment, so you don't have to do the last one. And also I deleted it from the test 1, so you don't have to do that. Okay, all right, so let's continue, and I hope you're doing well. And remember, we are going to meet in Blackboard Collaborate, and for this semester, because we don't see each other face to face, so I'm going to be there during your regular class time and answer questions. Of course, make sure you watch the videos before you ask questions in Blackboard Collaborate. Okay, so let me turn my video off. I don't think we need that, and start. So what I'm going to do, I'm going to go to the 2.7. 2.7 is about solving linear inequalities and absolute value inequalities. So what I'm going to do is go over the concept, go over the exercises, and as I go over the exercises, I talk about the concepts as well. Okay, so let's do the first one, the first few problems here. Let's see, I'm going to do the even ones and talk about some of the even ones, even numbered problems. So number 2 here says that when solving an inequality, we arrive at x plus 2 less than x plus 3, and then we get 2 less than 3. Explain what our solution set is actually in this problem. Well, we know that, let me get some space here we can write on. So we know that in this inequality, if I subtract x from both sides, I'm going to end up with 2 less than 3. What does that mean? Well, it means that no matter what you substitute for x here, this inequality will be a true statement, because eventually that x gets cancelled, and what you end up with is 2 less than 3. And 2 is less than 3, yes it is, right? Because on the number line, 2 is here and 3 is here. And obviously 2 is to the left of 3. That's what this means, right? So it means doesn't matter what number you substitute for x, this inequality will always be what? Satisfied. So that means the solution is all real numbers. Now how do you write all real numbers? Well, interval notation would be negative infinity to infinity, and you put parentheses. In set builder notation, you write x such that x is a real number. Okay, so that's that. Now, what about let's say number 4? What does that mean? That we get something like this. So what does that mean? Well, again, if you subtract x from both sides here, right? If you subtract x from both sides, we end up with 2 is greater than 3, and that's not true. This is false. Now, it means that no matter what you substitute for x, you can never make this inequality a true statement. You always end up with this, which is false. That means there is no solution. Now, how do we represent no solution? Either with empty set like this, or we just write the letter phi, which means the empty set. That's the same as that. You just don't put this inside here. There shouldn't be anything there. All right, so that's the solution for that inequality. All right, let's solve some of these inequalities. Write your final answer in interval notation. Let's do a few of these. Let's do number 8, and then we're gonna do maybe number 14, 8 and 14. So let's do 8 and 14. So let me go and to 8 and 14, show you the steps and why. So number 8 and 14. So here you go. This is number 8. So let me. So what we have to do is basically collect all the x's on one side, right? So here we have negative 2x. We have negative 2x plus 3 is greater than x minus 5. So what we have to do is move this x to this side and move this 3 to the other side. Now remember, when we move things around from one side to the other side of inequalities or equations, we need to change the sign. So here we have negative 2x already on the left. X comes to the left, becomes a minus x. This doesn't change, it's still the same. Negative 5 is on the right, and then 3 comes to the right, and it becomes, that's negative 5, and becomes negative 3. Right? So negative 2x minus 1x is negative 3x, and greater than negative 8. Now we have to divide both sides by negative 3. So we have to do that. But when we do that, we have to change the direction of the inequality. So the answer would be 8 over 3, x less than 8 over 3, not greater than. Well, let me show you here quickly why this is the case. You see, if I have 2 is greater than 1, and then let's say you divide by negative 2, then on the left I get negative 1, and on the right I get negative 1/2. Now, is negative 1 greater than negative 1/2? No, it's less than. Why? Because if this is 0, and this is negative 1, this is negative 1/2. So negative 1 is actually to the left of negative 1/2. So you see, we had a greater than inequality. When we divided by negative number, we had to change it to less than. This is also true when you multiply by a negative number. You have to change the direction of the inequality. Okay? So this wasn't directly related to this problem, but now, all right, so now how do we write the answer? Well, put it on the number line. Here is 8 over 3. Now, do we want 8 over 3? No, 8 over 3 has to be an empty circle. And then we want all the numbers to the left of 8 over 3. So in an interval notation, this would be parentheses. You put the endpoints here. The endpoint on the right is 8 over 3. The endpoint on the left is negative infinity. And then we put the comma. Okay? So that is the solution for number 8. Now we also wanted to do number 14. So let's go to number 14 and see why and how we can do this one. Well, in number 14, let's get some space so we can work on. So in number 14, what we have to do is, first we can get rid of the fractions. You get rid of the fractions, the denominators. So we can, now in algebra, there's a trick that whatever expression you have, you can multiply it by 1 and not change the value of it, right? So multiplying by 1 doesn't change anything. You could also add 1 and subtract 1. Well, if you add something and subtract something, doesn't have to be 1, it could be anything, right? So add something and then subtract the same thing. You don't change the value of this expression, you change the form of it. So what we can do here, we could just get rid of these denominators by multiplying by what? By 1, right? So for example, we can for we have 3 and 5, those are the denominators. So how do we get rid of both? Well, in order to get rid of both, we have to multiply by a number that is divisible by both 3 and 5. And what is that number? 15. So basically what we do, we multiply the inequality by 15, and since 15, and that is the least common denominator, is going to be 15 in our case. So it's 15. Now, so let me simplify it right here. So x minus 1 divided by 3 plus x plus 2 divided by 5 is less than or equal to 3 over 5, right? Now if I multiply this by 15 and multiply that fraction by 15 and multiply this fraction by 15, what do I get? Well, 15 times this, 3 by 3 is 1 and 15 by 3 is 5. So we're left with 5 and then x minus 1 plus, now 15 divided by 5 is 3, and then we still have x plus 2 there, and then this 5 and this 15, that's 3, so 3 times 3 is 9, so it's less than or equal to 9. Alright, so that is just a linear equation, and we can solve that. So let's do 5x minus 5 plus 3x plus 6 is less than or equal to 9. 5x plus 3x is 8x, and then minus 5 plus 6 is plus 1, less than or equal to 9. And then so 8x is less than or equal to, what's 9 minus 1? 8. So from here, x is less than or equal to 8 over 8, which is 1, right? So so the answer should be all the numbers to the left of what? To the left of positive 1, including positive 1, right? So all the numbers to the left of positive 1, including positive 1, would be negative infinity to 1 bracket for 1, because 1 is included. Alright, so we did those two. Let's do a few of this section. It says, for the following, solve the inequality involving absolute value. Write your answer in interval notation. Alright, so let's do number 16, and let's first do number 16 and we think about what else we can do. Now before we do that, let's talk about absolute value inequality. I think we did it in the previous video, but let me go over it one more time. Okay, so what we have here, situate my stuff here. So what we have is the idea of absolute value. So what is absolute value of x? What does that mean? Well, when I say absolute value of x equals to, let's say, 5, it means that I'm looking for a number whose distance from 0 on the number line is 5 units. So that means either is 5 or is negative 5, right? That's what this means. So when I write absolute value of x is equal to, let's see. So when I write, let me give you an example of that first. So when we solve this equation, basically what we have to say is, well, is either x is equal to this number or x equals to this number. So that means either x equals to 5 or x equals to negative 5. Now if we have something like this, then we say, we use the same idea. We say the inside, whatever the inside of absolute value is, has to equal to 5 or the inside has to equal to negative 5. So it means it either x is 6 or x is negative 4, because negative 5 plus 1 is negative 4. So that's how we solve absolute value equations. Now, what does it mean to solve absolute value inequality? So let me get rid of this quickly and then talk about absolute value inequality. So what does it mean when I say absolute value of x is less than 5? Well, that means I'm looking for numbers whose distance from 0 is actually less than 5. So what I'm looking for is absolute value of x less than 5, or I can put an equality here too, doesn't matter. So that means I'm looking for numbers whose distance from 0 is either 5 units or less. So that would be this one and this number. So any number over here would work, right? Because all of those distances from 0 are less than 5. So for example, 4.5, 3.9, 0 itself, negative 1, whatever number, right? So how do we solve this kind of equation? Well, if you only have number here, we just put what? We just put the stuff inside has to be between 5 and a negative 5. That's it, we're done. So if you have something like this, less than 5, all I have to do is what? X minus 1 less than 5 and greater than, well, there is no equality in this case, would be greater than negative 5. And then we isolate x in the middle, right? So isolate x in the middle, we have to add 1 to all three sides. And this would be x in the middle, 6, and negative 4. So the solution for this would be all the numbers between negative 4 and 6. Now in general, when we write absolute value of, when you write absolute value of something minus something else, by that, what do we mean? By that, we mean the distance between these two numbers. So that means absolute value of x minus 1 means what? Means what is the distance? What is the distance between x and 1? Now, when I put that less than 5, like in this problem, what I mean by that is that I'm looking for numbers whose distance from 1 is less than 5. So on the number line, if this is number 1, what are the numbers whose distance from 1 is less than 5? Well, we just found them. Is between 6 and what? and negative 4. And negative 4 and 6 are not included. So any number here would work. For example, 5. The distance from 5 to 1 is 4 units, and that's less than 5. So any number works. So think of the absolute value. When you see absolute value, think of it always of two numbers. Even though if we have absolute value of x, in this case, you can think of it as x minus 0. So what are we looking for? We're looking for numbers whose distance from 0 is 5, right? And x, of course, means numbers that we don't know, so they're unknown. Okay, now we can do a few of these problems. So let's do these. So let's do number 16. Let's do a few of those. So let's go to number 16 first. So here is number 16. So the way we do it is by starting with this expression. Now we just said that if we have something like whatever is inside the absolute value is less than some positive number, let's call it c, then the way we solve this is we put the inside the stuff between c and negative c. Now remember, the right hand side has to be a number. Now we're going to talk about what happens if it's an expression in a second, but for now that's what it is. Okay, so that means to solve this problem, all we have to do is what? Put 2x plus 3 between 7 and negative 7. Now subtract 3 from all three sides. Subtract 3, subtract 3, subtract 3. Now 2x plus 3 minus 3 would be 2x. 7 minus 3 is 4. Negative 7 minus 3 is negative 10. And now we can divide everything by 2. So we get 2 here, we get negative 5 here, and we get x in the middle. So the answer is basically all x values between negative 5 and 2, which is represented this way. Now, this was a shortcut. In reality, the method that always works is that whenever we have a situation like this, no matter what is on the right side, doesn't have to be a number, it could be another expression in terms of x, we can think of this as two inequalities that are connected with and. That means we want this stuff to be less than that, and also we want this stuff to be greater than negative or whatever that is. Now if we have variables here, it's kind of not possible to solve it the way that we did here. So what we have to do, we have to separate these into one inequality here, and then another inequality would be these two, and then we connect them with and. So we say the inside the stuff is less than that, and the stuff here has to be greater than that. And that's the way to solve these inequalities. What I just did here, it was a shortcut. So let's look at another problem, and this time we're going to pick one that has some expressions on the right. Let's see if we can find one. If they're all easy, right? So we get to those. Well, that's how we do it. Now, what about if we have greater than? Let's do one with greater than, right here, number 19. I said even one, so let's see. Can we find one that is even? Is there a 20? What about 21, 22? 22, that's the greater than. So let's do that. Well, 22 has no solutions. So I'm going to go back and find another one. There, even. There. We did that. Alright, we're going to have to do number 19. Alright, well, I went too far. Let's do number 19. There we go. Number 19. Alright, so the way it works is by first of all thinking of what this means when I put absolute value of a number is greater than, let's say, 5, right? Well, it means I'm looking for numbers on the number line whose distance, remember, from 0 or either, let's say, equal to as well, either equal to 5 or greater than 5. So obviously 5 works, and then negative 5 works, right? Because the distance from 5 and negative 5 is 5 units, and we want that. Now, we cannot choose any number here because the distances to 0 are all less than 5. So that means all the numbers over here and all the numbers over here would work for us. So to solve an inequality like this, we have to say, well, x has to be greater than 5, or not and, but or x has to be what? Less than negative 5, right? So now we are going to, and I see a typo already over here which says and here, it's supposed to say or. Okay. All right, so let's solve this together. I'm going to close it and open it so I don't have to erase everything. So here we go. So to solve this, what I'm going to do is I'm going to isolate this right here. So I'm going to get absolute value of x minus 2. And then 4 goes to the other side. It becomes 10 minus 4, which is 6. Now, we said we're going to think of this as two inequalities. Either x minus 2 is greater than or equal to 6, or x minus 2 is less than or equal to a negative 6, right? So that is easy to do. That's just a linear inequality. It means x greater than or equal to 6 plus 2 is 8, or x is less than or equal to, we add 2 to both sides, so we get negative 4. So you can put it on the number line. Here is 8. Let's say this is 8. We want all the numbers there have 8, and all the numbers after it. And then this is negative 4. We do want negative 4, and we want all the numbers to the left. So you see, if you put interval notation with or, this is negative 4 and negative infinity, and this is 8 and then infinity. Now, this has to be included because we want 8, and this has to be included because we want negative 4. And then this means union. That means we want both of these sets of numbers. All right, so that's number 19. So let's see what else. Let's go back here. Now, this one is very similar. Just have to multiply by 4 after you set it up, right? But I want to do a few of these. So what about these? It says, for the following, describe all x values within or including a distance of the given value. So how do we represent distance of 5 units from the number 7? Well, distance of 5 units from the number 7 would be absolute value of 7 minus 5 or 5 minus 7. right? So distance of 5 units, I'm sorry, let me rephrase that. Let me correct that. So we need distance of 5 units from the number 7. That would be all the numbers that are their distance from the 7 equals to what? 5 units. That's number 24. 26. Distance of 10 units from the number 4. Distance of 10 units from the number 4, right? That's what they mean by that. Okay, next, let's do one of these. It says, for the following, solve the compound inequality. Express your answers using inequality signs. And then write your answer with interval notation. So let's do number 30 and number 30 is good. So let's do number 30. So how do we do number 30? Well, this shortcut doesn't work for number 30, right? The shortcut doesn't work, so we're gonna have to think of another way to do it. So here we go. So remember, the shortcut was to try to isolate what? The variable in the middle. We can't do that. I can't isolate the variable in the middle, because if I add 2y's in the middle to get rid of it, then 2y makes the left side 5y, makes the right hand side 3y, so it's not going to get rid of it. So we can isolate the variable in the middle. It's kind of difficult, but if we divide this convert it into two inequalities. One inequality is this one right here, right? That means 5 minus 2y is less than 7 plus x plus y. And then the other one would be this inequality. Well, 30 is not included. Get rid of that. So it would be this inequality. That means 3y is less than 5 minus 2y. And then we have to put the letter and, the word and in between. Why? Because we want both of these to be true at the same time. We want 5 minus 2y to be less than 7 plus y, and at the same time we want it to be greater than 3y. Okay, so we have to solve these separately and see what they have in common. So let's do that. So 3y less than 5 minus 2y and we have to do 5 minus 2y less than 7 plus 1. Okay, so let's solve this over here. So that would be, I'm going to move the 2y to the left side, so I get 3y plus 2y is less than 5. That means 5y is less than 5. That means y is less than 1, right? And over here, I'm going to move the 2y. We can move the y to this side, doesn't matter. Negative 2y minus y, right, is less than 7 minus 5. Right? I move the y to this side and I move the 5 to the other side. Okay, that is negative 3y is less than 7 minus 5 is 2. Right? 7 minus 5 is 2. So y is less than what? Negative 2 over 3, because you have to divide both sides by negative 3. Now what is my mistake here? I have to change the direction of the inequality. So that would be a greater than. So remember, this is and here. So what we have to do is this. We have to put a number line for this answer. So let's say 1 is here I don't want 1, so this has to be empty, and I want everything to the left of the 1. And then the solution for the second one, negative 2/3. Now, your number lines have to be the same size, and the numbers have to be in the same places. So if 1 is here, this is 1 here. So negative 2/3 would be about, maybe this is 0, it would be about right here. Now, do I want negative 2/3? No. But I want all the numbers to the right of it, right? So, what these two have actually in common? They have this part in common, right? So, all of these numbers are good here. All of these numbers here are good because they're in both places. Now, 1 is here, but is not here. I mean, is here, but is not on the top. So 1 is not included. So the solution for this would be basically all the numbers from 1 to negative 2/3, right? 1 is not good, negative 2/3 is not good. Why? Because negative 2/3 is here, but is not here. It has to be in both places. So that means only the numbers what between negative 2/3 and 1 are solutions. So solution would be parentheses negative 2/3, right, comma 1. All right. So that's how we approach that. And let's see. Let's see. Okay, it says graphical for the following exercises. Graph the function. Observe the points of intersection and shape the x-axis representing the solution. Now here is when we think of this absolute value as a function and think of that as a function on the right, and then we graph them and see what they have in common. Now we can look at the graphs of them. We're going to talk about graphing more later, but I'm going to do a few of these problems for you. So here is like one of them. So absolute value of x plus 1 has to be greater than 2, but that's an odd one. So let me do this one, the even one. 34 is absolute value of x plus 3 is greater than or equal to 5. So what we do, first of all, if we were to solve this without graphing, it would be x plus 3 greater than or equal to 5, or x plus 3 less than or equal to negative 5. From here, x has to be greater than or equal to 2, and here x has to be less than or equal to negative 8, because you have to subtract 3 from both sides. Here we have to subtract 3 from both sides. Okay, so the solution would be basically, you see, that's what that is, and this is what that is, right? And that's the solution. Now, if you were to graph this, you're going to see that the graph of absolute value of x plus 3, the graph of that, is basically absolute value of 3 moved to the left 3 units. Now, normally absolute value starts at 0, so we're going to go to the left, right, and graph it, something like that, right, something like that. Now why the right hand side is just the straight line y equals to 5, the left hand side is y equals to absolute value of x plus 3. So we graph the absolute value here, right? Now I'm going to graph, let me erase the stuff here. So what I'm going to graph is this line right here, which is y equals to 5. And you see this point right here and this point right here are the solutions, or the intersection points right here. So this point right here on the x-axis, this point on the x-axis, and this point on the x-axis are the intersection point between this line and this function right here. And notice that the solution is all the numbers to the right of this number, which is going to be 2, and then all the numbers including this number to the left of it, which is actually negative 8. So you see on the x-axis we see the solutions, and that is where this graph, the kind of the V-shaped graph, is above the horizontal line. So for all of these x values, this function, which is the function on the left, is above the function on the right. And that's what greater means, right? Greater means more or above. In this case, in the direction of y, greater means above. If you're in the direction of x, greater means to the right. But if you're in the direction of y-axis, vertical, then greater means what? Means above. So 5 is greater than 3 means 5 is above 3. So the same is true over here. For these x values, you see that the y values for this function are greater than that one. But if you come over here, you see this actually is above the V-shaped graph. So wherever the V-shaped graph is above the horizontal line is the solution. And that would be over here and of course over here. Alright, so that's the idea of solving by graphing. You see, that's what it looks like. So this is 2 and this is negative 8, and you can shade the x-axis for the solutions. Okay, so that's what they mean by that. And here is more, and this time we have actually 2 lines. So what do we mean by x plus 3? Let's do number 38. So what do we mean by x plus 3 less than 3x minus 4? Well, that means we're looking for numbers. We can easily solve it without graphing, of course, right? Just isolate the x and you can find it. But what does that mean in 2D, in graphing? Well, it means this. Let me show you. So 33. Is it 33? Oh, 38. 38. So that's 38. Right here. So 38, it says x plus 3 less than 3x minus 4. So we're going to have to graph this. We have to graph the x plus 3, y equals to x plus 3, and graph y equals to 3x minus 4, and then see where they intersect. You see that? So that is, let me make it a little bit smaller, you can see. So that's the graph of x plus 3 and 3x minus 4. 3x minus 4. So this is x plus 3. Let me grab this so we can write on it. So we want y equals to x plus 3 and y equals to 3x minus 4, is it? Okay, here we go. Yeah, 3x minus 4. Alright, so 3x minus 4. So x plus 3, of course, you go to the y-intercept, which is 3, and then the slope is 1 over 1. So you go up 1, right 1, you get another point, you graph it, the blue one. And then 3x minus 4, you go to negative 4 on the y-axis, which is about right there, right? And again, the slope is 3 over 1, so you can go 1, 2, 3, and then go right 1. And that's the graph of the second one. Now notice that they intersect at a point. What point do they intersect at? Well, to find the point of intersection, you have to set them equal to each other. So x plus 3 equals to 3x minus 4, and then move the x's to one side. So x minus 3x is negative 2x, minus 4 minus 3 is negative 7. So x equals to negative 7 over negative 2, which is 7 over 2. So this number right here, where they intersect, you see this point right there, is 7 over 2, right? They intersect at that point. Now the y-coordinate, of course, it doesn't matter. You can put 7 over 2 here and find the y-coordinate, but that doesn't matter. We're interested in the x-coordinate. Okay, so what do we want to happen? Well, remember, what we want to happen is what? Is we want x plus 3 to be less than 3x minus 4. That means we want the blue graph to be below the red graph. So where is it here that the blue graph is below the red graph? Well, right here, right? So starting from this point on the x-axis, this point right here, to the right, always the blue one is below the red one. As soon as you come to the left of this number, you see that always the blue one actually above the red one. So the inequality that we wanted was x plus 3 less than, again I forgot, was it less than or equal to? No, just less than. We wanted to be less than what? To be less than 3x minus 4. That means we don't want this point itself, because at this point the two sides are equal. So that means the solution is just 7 over 2, not including, and then all the way to infinity, right? So that's the way we do it by graphing. But of course, we knew the solution. The solution is very easy to find, and we did it. You just move the x's to one side and isolate it, you get the solution. Alright, so that's what they mean by graphing it. And I think we are almost done here. Let's do a few of these. It says find the following, for the following exercises, write the set in interval notation. How do we do that? Well, let's do a few of these. So how do I write this in interval notation? Well, I'm looking for x, all the numbers between 3 and negative 1, not including what? 3 and 1. So I'm looking for all of these numbers, and you know how to write that. You put parentheses, parentheses, because they're not included, and you just put the end points here, right? Alright, so now for the next set of exercises, says write the interval in set builder notation. So we're going to write them in set builder notation, and that is, oops, what happened with my, oh, here we go, I lost it for a second, huh? Why do I lose it? I don't know what's going on here. Let me move it a little bit. Oh, they go away, they come back. Here we go. There. So in set builder notation, what would that be? Well, set builder notation, we have to go back to using inequality symbols, right? So what we want, for example, let's say here, what do we want? We want all x such that x is to the left of 6 but not equal to 6, right? So that means x has to be to the left of 6, but not equal to. That's it. And how do we do this one? Well, let's see. Well, x has to be, so x such that x has to be between 1 and -4, including 1 and -4. So x has to be to the right of -4 or equal to -4, to the left of 1 or equal to 1. And this means or x has to be to the right of 9 or 9. So that means x greater than or equal to 9. That's how we write it in set notation. And these are similar. You just have to. Now, we could solve equations using our calculator. So let's say I want to solve this equation right here. Let's do it by hand. And I don't know why I lose these. Something is going on. Let me see what is going on. Here we go. Come on, don't go away. Why do you go away? Just click here. Oh, goes away. Okay, well, what if we do this? There. Better not go away. Yes, it does. Okay, well, I'm not sure what's going on, but let's memorize one of them. So we want, there you go. So I want to use technology here. So I want this one. So what I'm going to do, now if we solve it, what do we get? So let's solve it. Please don't go away. Alright, there you go. Didn't go away this time. Okay, so let's solve it. So how do we solve it? Well, it's very easy. We know that we have to isolate x plus 2, right? So less than, if you add 5 to both sides, will be less than 7. And the shortcut works here. We just put x plus 2 between 7 and -7. So then subtract what? Subtract 2 from all sides. We get that. So we know solution is what? The solution is that x is between what? -5 and -9 and 5, right? Now here it says so what we want to do here, we want to find the intersection of these two using calculator instead of, so I want to use a calculator to do this. To use a calculator to do this, I'm going to just find the equation. So let me go back. So it says for the following, input the left side in y1, input the right side in y2, and so find the points of intersection, right? And then copy the sketch of the graph and shape the x-axis for your set of solutions. So let's do that. So let's use a calculator. So here's my calculator. So what I'm going to do, I'm going to go to y equals 2 and put, now how do we put absolute value of x plus 2? Well, we can go to math and number, and the first one is absolute value, and then just put x plus 2. So that's the absolute value of x plus 2, and then minus 5. So that's my y1. The y2, I just want to put 2 there. Okay, now we are going to go to zoom 6, which is zoom standard, and graph these. So as you see, if you don't see the whole V shape and the line, if this is not inside the, like for example, it is too close to the left, I can go to window and give the window a little bit more x min, right? So I'm going to go to window. You see it says x min negative 10. I'm going to make it like negative 15. And that's it. And then graph. Then get out of it and then graph. There. So it moves to the right a little bit. If you want a graph to go up or down, you change the y max and y min, or x min or x max. Okay, so what we're looking for is basically these two. Now what do we want? We want the V shape to be what? We want the V shape to be below the horizontal 2. So we want this V to be below this line. So where is it on the X that the V is below the line? Is from this number to this number. Now how do we find this intersection point? Well, we go to Y, you have to be on graph here. Then you go to second, calculate, and you see the intersection number 5, pick that one. Then it's going to ask you, what is the first graph? It's going to pick one of the graphs for you automatically. Notice that it's picking the V one. You can move it on the V, you see that. So that's good. We're going to pick that one. Then it's going to automatically go to the second one. Now if you have more than one function, more than two functions, it might go to the wrong one. So you have to move it up and down to the right one, you see. Right now is on the V, now is on what? Is on the horizontal one. Okay, that's my second. And then it says, do you have any guess? Yes, we want to go close to this. So I'm just going to go close to what? That point. That's my guess. And then press enter. And then intersection is given by negative 9 and 2. Right? So negative 9 and 2. That's this point. So we are interested in the x one. So from negative 9, right? And then what's that one? We do it again this time when we are asked to do it, to do guessing. We're going to go move to the, so I'm pressing this right arrow right there and press enter. So it's 5. So this number is negative 9 and this number is 5. So what is the solution? Well, the solution is going to be, let's see. The solution is going to be between 9 and what? Between negative 9 and 5, right? Now remember, we want this thing to be less than, we want it to be to the left of this number and to the right of that number. So the solution is x between negative 9 and 5. Now we don't want negative 9 and negative 5 itself because the equality is not included in the original expression that is given. See, equality is not included here. All right, so we are done with this rest of this chapter 2. I hope to see you in the next video. Okay, now I think you can take the test 1. Okay, so if you have any questions, email or come during the Blackboard Collaborate on Blackboard, or just email me and ask your questions. All right, so I see you next time, and take care of yourself.